tetrasaccharides and all kinds of saccharides. We'll go to the polysaccharides. Polysaccharides. Now the prefix poly means many. So many saccharides. And again, there's a million of these and all the rest of it. I'm going to choose polysaccharides only with glucose. It's not a requirement. It's just what I'm going to do. So glucose only. I don't feel like drawing out glucose, so I'm just going to do this. So lots of glucoses. The exact structure does not matter. Again, the exact structure does not matter. Just a bunch of glucoses. Polysaccharides in general are large branching molecules. Large branching molecules. Again, that they're all glucose is not a requirement. It's just what I'm doing. So just put anything down. Again, the exact structure does not matter because I just kind of made that up.
So, what is that abbreviation stand for?
So far, nothing. It's just a polysaccharide in general.
Oh, also just the glucoses?
Yeah, these are just glucoses.
Okay.
Yeah. But nothing in particular until right now. We're going to look at three. Starting off with glycogen. The C is hard. Glycogen. And glycogen is a large branching molecule made only of glucose. It is a major energy storage molecule in animals. It's a major energy storage molecule in animals. And that includes us. So basically, whenever we eat a meal, the sugar in our food gets transformed into glycogen. And we keep it that way, and then in between meals, if we need some energy, we break off a few chunks of glycogen and break down the glucose. You all know from other classes that we break down glucose for energy. And that's how we get energy in between meals. So glycogen, again, major energy storage molecule in animals. Now plants have a similar molecule. Anybody know what that molecule is? And you do know, or I wouldn't ask. Similar type of molecule, energy storage molecule in plants.
Starch.
Somebody, what?
Starch.
Starch. Exactly, starch. Same definition. Large branching molecule composed only of glucose and major energy storage molecule in plants. So what's the difference? The difference is the bonding pattern is different somehow. I don't know one from the other. It's just not important. But the bonding patterns are different, so you get different molecules. The starch is in plants. Obviously, we eat starch all the time. And we break it down and get the glucose. And there's a third one I'd like to throw at you. Cellulose. Same definition, almost. Large branching molecule, only has glucose, but it is not energy storage. And you might think, why not? Lots of glucose. Again, the bonding pattern is different. So apparently, we do not have the enzymes to break down the bonding pattern for cellulose. We do for glycogen, we do for starch, we don't have it for cellulose. So it'd be like eating a piece of paper, and it goes in one end, comes out the other. It doesn't do any harm. Well, it might hurt a little, but it doesn't do any real harm. Well, we can't use it. So some animals can, goats can eat anything, but we can't. So what exactly is cellulose then? It's actually a structural molecule for plants. It's a structural molecule for plants. Like trees, obviously huge. They don't have any bones, no skeleton, and yet they're really big. Well, cellulose gives strength and support to plants. So these are 3 polysaccharides. 2 of them we can use for energy, 1 we cannot. Again, I want to emphasize that it's always glucose. That is not a requirement. Many polysaccharides have other stuff in there. I just chose glucose.
Oh,
I'm sorry, what? I don't want to say that. We cannot. Like cows and goats do. They eat grass and stuff. But they actually do have a tougher time. It's harder even for those animals to digest cellulose than it is to break down sugar, for example. So they can do it, but it is actually more difficult. Yeah. Okay, so that's all we're doing for carbohydrates. Any question on carbohydrates before we move on? Okay. So the next category, remember we're doing the biological molecules, the organic molecules. The next category there was lipids. And I made the comment to you on Tuesday that this is probably the category you're least familiar with. Proteins you know about, nucleic acid you know about. Lipids probably not. Oils and fats. Oils and fats. Also significant parts of cell membranes. See, bacteria don't have a lot of fat. They do have cell membranes. So lipids are made up of fatty acids. Those are subunits, fatty acids. The fatty acids look like this. The exact number of carbons does not matter. So there are 2 parts to this. One, the first part there is called a hydrocarbon chain.
That entire chain.
This part, a hydrocarbon chain. Now hydro, for us, it usually means water, but in this case, it means hydrogen. A hydrocarbon chain has only carbon, only hydrogen. Period. That's hydrocarbon. Only carbon.
You got the first part, right?
Yeah, only carbon, only hydrogen. If it has anything else, sulfur, nitrogen, oxygen, it's not hydrocarbon. So literally by definition, only carbon, only hydrogen, period. The numbers can vary. I was saying don't worry about the exact number. the number can vary from 4 to 80. From 4 to 80. That's what these three little dots are. It means it's variable.
Nothing more than
Yeah. The carbon is what varies from 4 to 80. No. No, this part, 4 to 80. Here.
4 to 80?
4 to 80. That's this part. Now over here is the second half of this. Another chemical group called a carboxyl group. A carboxyl group. The carboxyl group is actually made up of two parts. Carbon double bonded to oxygen. That's called carbonyl. And then hydroxyl, that we've seen already. So carbonyl plus hydroxyl gives the carboxyl, which is this. And the significance of the carboxyl group is that it is acidic. It makes the entire molecule an acid. So whenever you see a carboxyl as part of a larger molecule, that larger molecule is probably an acid. So in this case, fatty acid. So this is an acid because of the carboxyl. Again, carboxyl is carbonyl plus hydroxyl.
So where do you find it? Where is it? Is it like in your body, or is it something that's like in
Fat,
any fat? Like butter? Butter fat, fat in your
those are lipids.
fat in your body. Okay, hello.
Oils, those are lipids. Now actually what I've given you here is called a saturated fat.
It's all called saturated fat. It's all.
What I've given you there is a saturated fat. Now it's saturated for two reasons. One reason is a little on the tricky side. Carbon, as you've heard already several times, has 4 bonds. So not counting the end carbon, all the other carbons are bonded to 2 carbons. So right here, bonded here, bonded here. Right here, bonded here, bonded here. And so on. So all the carbons have 2 bonds to other carbons, except for here. So what that means is there are only 2 bonds left over. 4 bonds total, 2 bonds are going to carbon. The other 2 bonds are always to hydrogen. That's the saturation. You only have 2 available bonds, and those are both to hydrogen. That's your saturation. And they're both saturated with hydrogen. Yeah. Again, carbon always has 4 bonds, period. You have no choice on it. Carbon has 4 bonds. So for all of these carbons, not counting the N carbon, for all of these carbons, each carbon is bonded to 2 other carbons. So 4 bonds, 2 automatically are going to carbon. So you only have 2 bonds left over. The other 2 bonds, hydrogen. So you actually only have 2 available bonds, and those 2 bonds are going to hydrogen. That's your saturation. So the available bonds are saturated with hydrogen. Now, like I said, that's a little on the tricky side. There is another definition that might be a little more clear. Saturated fats have all single bonds between the carbons, which is what this is. All single bonds between the carbons, that tells you saturated fats.
Oh, thank you.
Now, a lot of times, trying to show what something is actually easier to show what it is not. So, let's look at an unsaturated fat. Unsaturated. Now, I just said saturated fats. Yes.
So you said all single bond between the carbon tells us they're saturated, right?
Yes. So saturated fats have all single bonds between the carbons. We're doing unsaturated, so that means it does not have all single bonds. Let's put in a double bond. That would now be unsaturated. What? It has a double bond, therefore it's not saturated. I was waiting for somebody to show me the mistake I made on the board, and she did. The mistake is, with the double bond, carbon no longer has 4 bonds. Look at it. 2 bonds, 3 bonds, 4 bonds, 5 bonds. Can't do that. Carbon makes 4 bonds. So, to fix the problem, you got to take off those hydrogens. Now we're back to 4 bonds, 2 bonds, 3 bonds, 4 bonds. And the same over here. See, that would be unsaturated. First off, there is a double bond. It's not all single bonds. And second, you can very clearly see it's not a whole bunch of CH2s. Here, only 1 hydrogen.
So would you take out all the hydrogen for it to be that, or just those 2?
No, just where the double bond is.
Oh,
remember,
just with double bond is okay.
Carbon's got to have 4 bonds.
So if you were going to ask this question on a test, how would you ask it?
I'm sure it'd be tricky as can be.
So would it be like, I don't know, I'm just trying to get an idea of like, because a lot of wording is different, you know? So I'm just wondering, like, you know, do you have like an example?
I have nothing in mind.
No?
But I could just ask you something like, how many hydrogens are on unsaturated carbons?
Oh, so many hydrogen.
The answer would be 1.
Right.
Because the hydrogen on a saturated carbon would be 2.
Good.
Or I could ask you about a double bond or single bond. Yeah. For an unsaturated fat. Yes. Yes. Absolutely right. And that's exactly where I was going next. She raised a very important point. This is unsaturated. That does not mean you can only have 1 double bond. You can have lots of double bonds. So let's put another one in. I'll put in one there. So same thing again. Remember, carbon has 4 bonds. You're always stuck with that. So if you put an extra bond somewhere, you have to take away hydrogen. Just stick with 4. But this is now polyunsaturated. This is a polyunsaturated fat. Go ahead. You have a
Would you
question.
ever have a triple bond or only?
You know, not really. I don't want to say no, because, man, anything's possible. I'll just say triple bonds are rare. I don't want to say it's not possible, but it's not very likely.
So then if you ask the question, how many hydrogens in an unsaturated?
No, definitely
Then it
assume
wouldn't-
double bond.
Okay.
Yeah,
So
definitely.
you want
Yeah, I'm not going to touch the triple bond yet. Because that would change the entire thing.
Does it change the molecule if you take the top 2 hydrogens off versus the bottom?
It does actually, and it would give you different properties. I'm not going to worry about that, but I'll just throw something out at you off the record. Off the record means it won't be on a quiz. It's just information. So I've been taking off the hydrogens on the same side. If I had something like that, that's a trans fat, which many of you have heard of. You know, a lot of talk about trans fats not being very healthy for us and so on. That's a trans fat. When you have a hydrogen on either side of the double bond. Again, off the record, this is not a nutrition class, so we'll stick with
Make
that.
it worse for you if you have 2 of them?
I'm sorry,
Could you have 2 of those?
do what?
On the
Of
other
the
double
trans?
bonds, yeah.
Oh, you bet. Sure you
Only
could.
double it down.
Any effort to get really bad, yeah. So anyhow, polyunsaturated just means 2 or more double bonds. And you've already picked up, there's still variations beyond that. But we're not going to go there. And wherever you have a double bond, you're going to have essentially CH1 instead of CH2. And so on. Now, I said this is not nutrition, but still, it turns out that
It's right here next to the paper towel.
thank you. Don't go away. Thank you. Turns out that saturated fats are found mostly in meat, and particularly red meat, and the unsaturated fats are found mostly in plants and vegetables. Now, you've all heard stories that people who eat a lot of red meat and so on tend to get clogged arteries later in life. Well, it's because the saturated fats don't break down as easily. The unsaturated break down more easily. You might wonder why, because the double bonds are stronger than single bonds. Well, the reason is because, enzymes. We need enzymes for digestion. The enzymes can come in very easily and start chopping away. With the saturated fats, see, it's more crowded. It's more difficult for the enzyme to get in there. So yeah, a lot of red meat in your life, yeah, you do have a higher chance of clogged arteries, et cetera, et cetera. And if you're eating a lot of plants and vegetables, then you probably have a better chance of being healthy and so on. I do have several friends who are vegetarians, and they've always told me how much better they have felt since they became vegetarians. I tell them, yeah, I agree, they probably do, as I order my prime rib, that they probably do feel better. The thing is, I mean, if somebody's a vegetarian, I'm sure somebody here is, it's fine, but it's not really a requirement. As humans, we are classified as omnivores. I mean, omni means we can eat anything, meaning meat or vegetables, as opposed to the carnivores. Those are the meat eaters, lions and tigers and bears, and usually dogs, but my dogs eat grass. I still haven't figured that out. And the herbivores, by the way, the H is not pronounced. I hear people saying herbivore, it just makes my teeth grind. It is herbivore. And these are the grass eaters, you know, cows and sheep and stuff like that. But we are made to eat both meat and vegetables, so there's nothing wrong with that. But like anything, you don't want to overdose. You want to kind of balance it. So, at any rate, so saturated fats found mostly in meat, particularly red meat. The unsaturated fats mostly in plants and vegetables. Any questions on that? Is that okay? Because I've left one important thing out. We haven't done a lipid yet. These are fatty acids. These are subunits of lipids. We have to make a lipid. Okay. So, like I did with the carbohydrates, I want to show you an easier, better way of drawing this. The CH3 is your N carbon. It's your N carbon. The CH2s are all of these. It's all of these. Now, of course, as you know, the number of carbons is variable. You know, we don't exactly know how many are there. That's what the N is. The N is your unknown. So obviously ranging from 4 to 80. And then the carboxyl at the end. Now there is one flaw with this. It's a little more subtle than the other one that was, you know, the carbon having 5 bonds. The flaw here is a little more subtle. The subtle thing is that this notation here really is for saturated fats. Because those are the ones that have all the CH2s. If you think back on the unsaturated fat, anyhow, that has CH1. So this really does not apply to an unsaturated fat. So basically, I'm going to say I don't care. So we'll use this for both saturated and unsaturated. Just simply fatty acids. And just kind of have the knowledge, it won't really affect anything. But just be aware that it might be unsaturated. And that's not being shown here. But we'll use it anyhow because it's easier. So with that, I want to erase this thing. We don't need it anymore, and we'll just use this.